All right, so the top here, we're just kind of talking about what we looked at yesterday, just reiterating a few things. So yesterday we talked about how we could approximate the values of a function near a value of x using the tangent line. So here's our a, f of a, that's our point of tangency. If we look at a point on the line right here, it's going to be really close to the point of the function. Right? Anything that's kind of close to this point of tangency is going to be a pretty close approximation. It asks us to write an equation of the tangent line of L. Well, tangent line, we've got our point here, and our slope of the tangent line would have to be the derivative at that point. So our slope would be the derivative of f of a. So we get y minus our y value is f of a equals our slope would be derivative of f of a times x minus our x value is a. So this would be our tangent line, right? And we could solve for y over here. We get y equals f of a plus the derivative of f of a times x minus a. Well, that equation right there is that linear approximation that we talked about. We can say that f of x, this function right here, is going to be pretty close to this line, as long as it's close to that x value where it's tangent. So as long as x is close to a. Right? If we try to x value way out here, that's going to be way off. That line's going to go, we're not going to have a good approximation. But as long as it's close in this region, we're going to get a pretty decent approximation of our function just using a simple line. And so let's go ahead and take a look at number 2 for today. All right, one other thing before we look at 2, this is another term you might see, linearization, instead of like linear approximation. That's the same. Right. A lot of the ones we're seeing say linear approximation, but if it says linearization, that's just the same thing, finding that equation of the tangent line to approximate our function. But we're going to go ahead and start off with number 2 today. We didn't really get to too much trig yesterday, and I did mention though yesterday that all trig problems must be in radians. It just won't work if it's in degrees. So you'll be given some problems where it starts off in degrees. You need to make that conversion. Right? You can't do it with degrees. It's not going to come out right. So does anybody remember how do we go from degrees to radians? One of those two, right? Either pi over 180 or 180 over pi. If we're trying to go from degrees to radians, we want the radian part on top, right? So we're going to multiply by pi over 180. So in these examples here, this one we're trying to approximate sine of 32 degrees. And we're using the point when x is 30 degrees. That's going to be like our nice value. That's where we're finding our point. But we want to put these in radians. So 30, that's pretty simple to do. What's 30 in radians? Pi over 6, right? 32, we're trying to approximate what's f of 32 degrees, but we don't want to write it in degrees. So we can write that in radians just by taking 32 times pi over 180. Now we could simplify that. And that's what we're trying to figure out. We could simplify the 32 pi over 180, but let's not, because what's going to happen, sometimes we'll simplify and then later we're going to have to change it again. So just leave it as is until later. If we need to, we can simplify it later. All right, so we've got pi over 6 and 32 pi over 180. So our function here, our f of x, well, what's that going to be? Sine of x, right? We can take whatever we're trying to approximate here, just replace the number with a variable. So our function is sine of x. The point that we have, right, we need a point and a slope. Point comes from the nice x value. Well, this is our nice x value, right? That's where the point of tangency is going to be. So our point has an x value of pi over 6. To find the y value, we just have to find out what's sine of pi over 6. So what's sine of pi over 6? 1/2. Alright, so we have our point. Then we want to find our slope. Well, for the slope, we need to figure out the derivative of our function. So derivative of sine is cosine. So we want to find the derivative when x is pi over 6. So what's the cosine of pi over 6? Root 3 over 2. We need to know our unit circle stuff here. Right, so square root of 3 over 2 for our slope. Right, so we have our two parts that we need to write our tangent line. We get y minus 1/2 equals square root of 3 over 2 times x minus pi over 6. So that's the equation of our tangent line. But then we can make that little slight alteration to write our linear approximation. F of x is going to be approximately equal to 1/2 plus square root of 3 over 2 times x minus pi over 6. Right, just adding that 1/2, and then we're doing f of x approximately equals that. Right, so our function is approximately that. We can go ahead and put in our value that we're trying to approximate. Remember, we're trying to approximate f of 32 pi over 180. So f of 32 pi over 180, we're just substituting that in for x. Now, these trig ones don't always look the prettiest when we're all done with them. This is why I said not to bother simplifying. If we would have simplified this 32 pi over 180, we would have had 8 pi over 45. But then we'd still have to get a same denominator here with the 6, and we'd have to multiply this. So now we can kind of do this a little bit easier without extra simplifying or rearranging. Pi over 6, that's the same as 30 pi over 180, right? We can multiply top and bottom by 30. So we end up with 32 pi over 180 minus 30 pi over 180. We have 2 pi over 180. So those 2's can cancel out. And we're left with 1/2 plus square root of 3 pi over 180. Now with free response, that's fine as an answer. But multiple choice, I've seen sometimes they will have this written as one fraction, like one expression here, instead of adding two things. So if that's the case, we would make this 90 over 180, right? Get the same denominator plus square root of 3 pi over 180. So you could write that as 90 plus square root of 3 pi all over 180. So that's just for multiple choice. You don't have to take those extra steps in free response. The boxed answer is fine for a free response question.